Hi there! Welcome to my channel! Today I will be teaching you about testing hypothesis, and our first topic will be t-test for dependent samples or correlated samples. Here we go!
T-test for dependent or correlated samples. Types of data that consist of information obtained from matched pairs or repeated measures are classified as dependent or correlated samples. Repeated measure analysis is a design in which each subject is measured at two or more points with respect to time. Now we consider this question. Are physical exercises effective in reducing weight? We could just easily say yes, based on our observation, but in statistics, we verify our answers based on a given data. Let's take a look at this example. In a study of effectiveness of physical exercise in weight reduction, a group of 10 persons engaged in a prescribed program of physical exercise for one showed the following results. We have the individual on the first column. On the second column, we have weight before expressed in pounds. And on the third column, we have weight after expressed also in pounds. Notice that in the given data, we have two outcomes. We have the weight before and we have the weight after. Now, we will use the 0.05 level of significance if the prescribed program of physical exercise is effective in reducing weight. Now we have our solutions. Our first solution is to set the null and alternative hypothesis. Let's recall the first slide. And that will be our basis of our hypothesis. Setting the hypothesis, our null hypothesis states mu sub 1 is equal to mu sub 2, that the mean weight of persons before and after the physical exercise program do not differ significantly. And our alternative hypothesis, mu sub 1 greater than mu sub 2, states that the mean weight of persons before the physical exercise program is greater than their mean weight after the exercise. Now we proceed to our solution number 2, which is to determine our test statistic. We will be using t-test for these dependent samples. On step 3, we have to set our level of significance at 0.05. For step number 4, we have our decision criterion, which is to reject the null hypothesis if the test statistic is greater than the critical value, where 0.05 times 10 minus 1 is equal to 1.833. Now, how are we going to get the 1.833? We will be using now the T table. We will open the internet, and on the Google, we type the T table PDF, click, and here it is. We have now our T table. Notice on the previous slide, we have our 0.05, which represents our alpha, as indicated here in the formula, while 10 minus 1 represents our n minus 1, which is 9. So we will take note of the values 0.5 and 9. Now we go back to our PDF, and I suggest that we should zoom it out and locate the number 9. This time I will be using the aid of the tools. Now locating 9 on the degrees of freedom and one tail that is 0.05. Now we will have the intersection and we will use the color blue to give emphasis. So we have So here it is. We have 1.833. So that is now the way to find 1.833 as our critical value. Now we go back to our slide. That is 1.833. Now let's proceed to the step number 5, which is the computation. We have the first column, individual, the second column, weight before pounds, and weight after expressed also in pounds. Notice that we have the fourth and the fifth column, which represented by d sub I and d sub I squared. Now, d sub I represents the difference of the observations in weight before expressed in pounds and the weight after expressed in pounds. So we have the value 4, which is 200 rather minus 196. That is 4. On the second, we have 178 minus 171, we get 7. And we do the repetition of steps to get the difference. Now, on the fifth column, we have d sub I squared. We're going to square the fourth column. And that is 4 times 4, that is 16. 7 times 7, 49. And negative 1 squared is 1. We will also repeat the same steps in column number 5. Now, on the last part, we are going to add all the given data. For the weight before pounds, or weight before expressed in pounds, we got 1871. And for the weight after expressed in pounds, we have 1826. And for the d sub I, we have 45. And for the d sub I squared, we have 309. Now, we are going to solve first the mean difference. The mean difference is obtained by using this formula. Now, mean difference is equal to summation of the difference of the observed values of the weight before versus the weight after of the nth individual over the number of subjects, and that is n. So, by substitution, we get summation of the difference of the observed values. We have 45, which we have taken here, and our n stands for number 10, which is the number of individuals. 45 divided by 10 is 4.5. Now that is our mean difference. Now we are going to solve for the variance of the mean difference. We will use the formula. We have the variance of the mean difference is equal to the summation of the square of the difference of the observations from weight before versus the weight after minus the square of the summation of the difference of the values observed from weight before to weight after over the n, all over n times n minus 1. Remember that n represents the number of the subjects, which is 10. Now, by substitution, we get 309, which we have taken from this table, and 45 squared from this table divided by 10, all over 10 times 10 minus 1. By simplification, we have now the variance of the mean difference is equal to 1.1833. Now, on the next computation, we have already the mean difference, we have 4.5, and we already have the variance of the mean difference, which is 1.1833. The next thing that we are going to solve is to solve for the test statistic, which is the quotient of the mean difference and variance of the mean difference. By substitution, we got 4.5 divided by the square root of 1.1833 is equal to 4.137. Now, on the decision, step number 6, we have since test statistic is equal to 4.137 greater than the critical value which is 1.833, we are now leading to the conclusion to reject the null hypothesis. And rejecting the null hypothesis means here on step number 7, we have now our conclusion. Based on the result, it can be concluded that the weight before the physical exercise is significantly larger than the mean weight of the subjects after the physical exercise as the treatment. The result further reveals that there exists a significant reduction of weight as indicated in the test. Therefore, the prescribed program of physical exercise is really effective in reducing weight.
This time, I will be teaching you how to do statistics in Excel. On my desktop, I will be finding the data which I encoded earlier, and that is on book 1. Double click, and here it is. We have three columns: individual, weight before pounds, and weight after pounds. Just make sure that all data encoded here are accurate. Next thing we do is to click data, find data analysis, click, and a pop-out will appear. Scroll down and find t-test. We have three t-tests here. We have t-test for paired two sample for means, t-test for two sample assuming equal variances, and t-test for two sample assuming unequal variances. This time we'll be selecting t-test paired two sample for means. Okay, and then we have the input. Variable 1 will be representing the weight before pounds. So to encode the data, we are going to drag the cells and repeat the same steps in variable 2 representing the weight after pounds. Click labels and then notice that the alpha or the level of significance is already set to 0.05. Now on the output range, this will tell us where we wish to put our results. This time I will be choosing E1. Then click OK, and then here it is. Now I'm going to highlight the values reflected on our computations earlier. It stated or reflected here that our T statistics is 4.3013 or 4.137 greater than our T critical, which is 1.833, which supports our claim that our null hypothesis is rejected. And we're done. I hope you are learning. Thank you.